So once everybody gets seated, I guess we'll get started. It is 12:30. So, how's everybody enjoying Zenkaikon so far? I will say this much, this is actually my first year being here. I've never attended Zenkaikon before. I'm based out of New York, so I'm local. My name is Charlie. This is my lovely wife Amanda. We're owners and proprietors of CS Custom Props. So we do full commission props out of foam. I'm also working on bringing 3D printing into that as an on-demand 3D printing service, which would allow you to use the layers that I have up here. The whole point of this panel is essentially to give you information about what 3D printers are, a basic primer on them, what's some information that I've learned a lot of people want to know about 3D printers before they go and make a purchase of a 3D printer, or if it's really even worth it for them to purchase one or just use a service. Also, it gives you ideas of what certain items are that you can 3D print that are beneficial to your cosplay in specifics. So, the panel is titled 3D Printers and How They Can Up Your Cosplay. So the first question that I get is basically, what is 3D printing? So the dictionary definition of 3D printing is the action or process of making a physical object from a three-dimensional digital model, typically by laying down many thin layers of a material in succession. There are two main types of 3D printers on the market today. There probably will be more at some point, because this is a technology that is just doing nothing but growing and growing. So the first one is fused deposition modeling, which is an FDM printer, which is what all of the items you see in front of you here today were printed on. Then there are stereolithography, or SLA printers. Those are your ones that you see that are more resin style printers. So here's some more information about FDM printers. They're the most common type of printer. Normally when you Google 3D printer, these are what you're going to find. This is what you're going to see. They're the most common made. They're, the way that they print is they use spools of filament. So you have a string of filament that is fed into the machine. It's heated and deposited on a heated glass or a composite bed. Multiple different materials to print from. That's one of the benefits of an FDM printer. You can print in PLA, which is what all of the items up here are printed in, which is just a type of hard plastic. You have ABS, which is also another type of plastic, but it's a little more flexible. You have nylon, PETG, carbon fiber, and now you can actually even print in carbotanium, which is carbon fiber mixed with titanium strands, as well as there are 3D printers out there that will print in metal. That's way outside of anything I feel like any cosplayer would ever want to purchase. The other big one currently is what is called Ninja Flex, which is a flexible filament that once it is printed, you can actually take it off of the printer, stretch it after it's done. So I see a lot of people that do Venom, Carnage, all of those kinds of masks. You can actually print the whole helmet, take it off the printer, stretch it, and it will stretch over your head. Like, that's the whole point of Ninja Flex and TPU, or it's another type of calling it. These machines are relatively low maintenance. They don't really have a whole lot of bits and bobs to them. They're kind of, everything's exposed, it's just basically keeping dust off of them, keeping certain items lubricated with a little bit of oil, keeping dirt off of them. You can leave them into the open air. You can make an enclosure for them if you wish. The other thing that's nice about these is they're very customizable and they're very upgradable. These printers basically all, for the most part, look the same. So because of that, almost all of these printers are what they consider open source. So you can upgrade your print heads. So you can make, so we're talking 200 to 300 degrees Celsius. Certain items will melt before that actually happens, parts of the printer. So you can upgrade the print heads, you can make them direct drive. You can actually print 2 different filaments at the same time, 2 different colors. Make one start, print up so high, so you want green, then you want to do blue. It stops the green, and then you print with the blue. So the other thing is the price point. The cheapest one that I've found is right around $150. Now that's a relatively small one, But like I said, you want the metal one, you're looking into multi-thousands, tens of thousands, or 30,000 probably dollars. Most everyday ones you want, you can go up to $2,000, and that's just based on the size. Stereolithography printers, they are commonly called resin printers, only capable of printing in UV hardening resin, so that limits what you can print with, whereas these FDM printers can print with multiple different types of materials. These will only print in UV curing resin. The way that they work is you basically pour a liquid resin into a vat in the base of the printer. The print bed is then lowered down into the vat. The UV light is then laser shot into the resin and cures the resin as it's pulling the bed up out of the liquid. So if you actually watch videos and you really kind of want to see satisfying 3D prints, these are really cool time-lapse videos because it literally goes down into liquid and then a solid object comes out. These also do require more post-processing due to the slightly hazardous materials that they're made out of. Resin is not something you want on your fingers, so you're always going to need gloves when you're handling it. They also have UV light, so the actual part of the printer will block UV light from sitting or from coming out of the printer. With that, you will also need a cleaner. You'll need a butt ton of isopropyl alcohol. And a lot of them actually require a curing station after it's finished printing, just to make sure the exterior layer of resin is completely hardened. These printers are more for printing smoother details. So let's say you want to print a figure, or an action figure, anything that has a lot of detail, or even some of the statues that you can see down in the dealer room. You can print them on a resin printer because they're using laser UV light to cure the item. So you get a lot of heavy, fine detail. Now, as for price point, the prices of these have come down over the past couple of years. I've seen some for right around $200, but like I said, the most expensive one that I found just from a quick Google search was $10,000. But those are actually ones that you see a lot of medical printing done. They can actually 3D print functioning body parts. They will 3D print ears, things like that. So the main other question I get is, how do you choose? The biggest thing that I tell people is your print bed size is the only thing you can't upgrade easily after you purchase a printer. So the most important detail, like I said, is the print bed size, and mainly because it can't be upgraded later. The printer is set up, its print bed size, it knows how big it is, so it knows that it can't print outside of a certain area. The bigger the bed, the larger items you can print. The printers that I currently use, I can 3D print an entire Stormtrooper helmet in one go. I don't have to cut it up, I don't have to glue it all back together, it will print, and I can make the whole assembly. So basically having a bigger bed means you can print larger items and not have to cut them up and not have to have as much post-processing. The other thing you have to consider is the space. So the amount of real estate that your printer will occupy is very important. If you don't have a lot of space, then larger printers will be harder to house. The other part to this is a lot of printers' materials are temperature sensitive. So having a relatively well climate-controlled environment is very important. For instance, PLA is kind of a little less finicky, but you move to ABS. If you literally open a door in a room that has a 3D printer printing ABS and you swing that door open quickly, that little gust of air will cause that print to actually shrink in at least 10%, like that. And then now you've thrown off that whole print because it needs the temperature there. Isolation is also important. You don't want Fido or Fluffy bumping the printer while it's running or printing a large printer. Again, you also don't want them to burn themselves if they get up on the table because most printer heads are running at double the boiling point of water. So they're very hot, and I have the calluses to prove it. The other thing is we've learned this as well. Cats tend to really like to eat filament. At least ours does. I don't know if everybody's Capico, but it's not fun when they start hacking it up. So that's the basic on the printers themselves. So now this is where I kind of get more into how 3D printers will help cosplayers specifically. So the things you can make. This is kind of, we're going to delve into my stupidity here in a second. So the reason that this helmet actually has a flap on the back made out of EVA foam is because I actually got my head stuck in this. Because when you're printing something, it gives you dimensions of the object, but it gives you the exterior dimensions of said object. Not interior dimensions of said object. Got my head in, could not get my head out. And it took everything I had to actually break this to get my head out. So then I actually took it and enlarged it to a size that would fit my physical head by using cardboard and making a flap here. This is a helmet that's just kind of in the process of me creating it, and then I'm going to re-render it so that I can fit it. So this is, like I said, wearable items. The other one here is actually a file that I purchased from a designer for border. At it, and I was like, I can't make that out of foam that nicely. So this is one of those benefits where 3D printing, because of it being so print itself, to give you an idea as to time, this was a week and a half of just printing. Everything goes perfectly. The next one is the big old sword you guys see down there on the bottom. I'll actually get down to it real quick. As you can see, it's printed in multiple pieces, just because you can't print something this large on a normal size printer. Doing that. If I do it any harder, it's going to snap right in half. There is actually a wooden rod that runs through this whole thing. And it's all glued together, everything like that. But this is not something that I would consider to walk around the con all day wearing or use it, because it will break at some point. 3D prints are great, but this material is a little too flimsy for that kind of stuff. The design of this file was a little bad because there's actually no hard material. The actual wooden rod stops here. It doesn't actually go down into the handle. Like if anybody has ever made a sword out of foam, you know, you put the stick all the way through the handle so that it doesn't snap off here. But just to show, this is something that you can do. It's not outside the realm of possibility. Go ahead to the next one. Small detail items and props. Pokemon Arceus. Pokeballs. Overwatch. Genji Shurikens. The other ones are for my Creed cosplay. You can 3D print nuts, bolts, all that kind of stuff that you can just glue to stuff, glue to it. The other nice thing is not only are they actual, they do actually function. Sorry about that. So here's another one. I don't actually have anything here to show this off, except for this. So this is another thing when you get a 3D printer, you start finding things to 3D print. This is a holder for my PlayStation 4 controller and my Move controllers for my VR that allows me to also plug them in. Simple, quick, and easy. But the filament I used for this helps with lighting effect details. So let's say you have a piece of armor that you want to light it up, but you can't find something that looks like what it's supposed to. This is called a natural filament. As you can see, you can't really see completely through it, but if you printed this, you could literally put a light behind this and it would light up. And it would diffuse the light as if it was just a glow. So this is another area that a lot of people don't think of when they think of 3D printing. Oh, I can't do that, or I can't make gemstones. I've made gemstones that go in lighted crowns that do the same basic idea. Hardware and accent pieces, that would be kind of more the screws, bolts. You know, let's say you want to make teeth that go on a necklace or anything like that. The other thing that I actually just started printing, and I learned how to print for this, chainmail. Yes, you can print fabric. So this is actually chainmail that is printed in place. I did not do anything to this. Literally came off the print bed. I went like that, and everything was loose. And you can see how much this folds, moves. And this is probably not even a quarter of the weight if you would try to make it out of metal, even aluminum. But for something that are smaller detail areas, I printed this small square. I was able, there's a file that this person created that is 230 millimeters by 230 millimeters. So it is literally the entire bed of my printer that I can print this. And then he actually makes links so that you can connect other ones together. So you can make large sheets of this. If you want to make a shirt, go ahead and make a shirt. Now the other ones that a lot of people don't think about are utility items. So you're going to a convention, you get to your hotel room, you learn, as everybody does, there's never enough room in a hotel room to store all of your cosplays before you go to the convention. That's where these guys come in. This is literally a 3D printed wig stand. And it's literally simple. There's a peg, there's pegs in it. Take it apart. And then that goes in your luggage just like that. So simple little things like this that, like I said, when you get a 3D printer, you start coming up with things to print. Like, I never would have thought to print one of these. I was this close to buying one from like Arto Wigs for $20 or $30. It cost me not even a tenth of that to make this. So here's a little bit more helpful information that will get you started should you get a 3D printer. Almost all prints require some level of post-processing. And by post-processing, I mean our favorite: sanding, primer, wet sand, cry, sand some more, prime. And then after about 3.5 weeks of all of that, you might be able to put paint on it. Not all of them are that bad. However, anal retentive do want to do that. For instance, this one here, I actually had a failure in this print. In the middle of the print, about 3.5 days into this print, this thing shifted just a tiny bit. But it wasn't enough that it didn't fail the whole print where it would not be printed at all. So I thought to myself, can I fix that? Or do I want to start a 6-day print over again? I chose to fix it. And you can't actually see it, but I used body filler in almost all of this section of the mask to fill it in. And then it's been primed and everything. So that way you really, from a distance, you can't see it. If I would paint this and I'd be wearing it, taking photographs, you probably would never see it. Now, if you actually look at the back side of it, you'll actually see all the layer lines, because I don't really care about the back side, because that's going to be on my face. Nobody's going to see that, except you guys. You guys get a special. The other thing is there are also certain programs that you're going to need for 3D printing. All 3D printers require what's called slicer program. That literally says what it is. It takes a 3-dimensional file, or an STL, or an OBJ file, and it turns it into layers. It slices it down to a layer height. And that is what then is fed to the 3D printer in code that it understands, and then the 3D printer takes it and then runs its head in those layers. So there are multiple different slicer programs. Almost every company has their own variant that they'll give it to you when you purchase a printer. Cura is one of the best, in my opinion. It's one that I use. It's an open source, it's free. It will work with just about any printer. It will work with resin printers. It will work with FDM printers. And there's actually a whole lot of different add-on things that will work in that. Prusa is another one. They make their own 3D printers, but they also make their own 3D printing software that works with almost any kind of printer. Some of the things that I remember with Cura is Cura actually has, I just found out about this from talking to another gentleman that's into 3D printing. Most people don't think about this as another option for 3D printing with cosplay. Let's say you want to make something, but you have to make, say, 40 shurikens that you want to stick on a sash or whatever. That shuriken there that I printed, that took almost a day just to print. Now imagine you got to print 40 of those. That's a waste of my time and everybody else's time and my electricity and my filament. Print one. Make it a mold. Make a mold of it. Most people, that's what they use 3D printers for, is to make masters, to make a mold of. Now I also learned, Cura just added this feature. If I have that 3D file in there, I put it into Cura, you can tell Cura, print mold. It will literally print you a 3D printed mold of that object. So it'll come off the printer, you can glue it together, stick it together, and it will be ready to be poured. And it will give you very tight tolerance. So that's another thing, that Cura being open source, that's something people have added to it. The other ones are 3D rendering programs. If you decide you want to make your own files, you know, you're adept at it. I am not. I'm learning. It's a very steep learning curve. The one I currently use is Blender. It is a free to download file or program. It's a little different because Blender is actually made for three-dimensional animation, like Pixar, all of them. That's kind of that stuff. So what you're using Blender for is literally like not even 10% of what it actually can do. Another one that a lot of people recommend is Tinkercad. Tinkercad is a web-based, free-to-use CAD software that you can use to create 3D files. Another one is Fusion 360. Fusion 360 is one you can purchase, but also if you're a student, an entrepreneur, or anything like that where you own a small business like I do, you can download a full Fusion 360 for free. Now when it comes to people that don't want to pull their own hair out, figuring out vectors and all that, vertices and all that other stuff, you have 3D pre-made 3D files, which is pretty much what you see up here. Somebody else took the time, created the file, and then left it to everybody to use. The biggest one on the market right now is Thingiverse. Thingiverse has somewhere close to 60 or 70,000 files, free to download. All of the stuff is free. Some people ask if you want, you can buy them a coffee or donate $1 or this, that, and the other thing. Other ones are Etsy. Etsy, a lot of people create a 3D file, put it up on their Etsy store to sell. Cults 3D is another new one that just came around. They offer free as well as pay to purchase files. The other big thing that I always tell people about 3D printing is this is not a foolproof system. You will have failures, so don't get discouraged. For instance, I brought, and some of the pieces up front there are what I call the box of rejects. So this is the handle for that sword up front there, one of them. I tried printing this 5 times before I actually got that one. This, just to where it got to here, that was probably about 1.5 days of printing, and then it failed. As you can see, the problem is down here. It actually was unadhering from the bed. Same goes for, I actually printed that whole blade once already. In this one, you can actually, you won't probably be able to see it, but the hole that's designed for the stick that goes through that sword blade, the bed, it actually lifted the print up off the bed, so now the hole is not round anymore. So there's no way I'm gonna get the stick inside. So guess what, that's junk. This is actually another thing for, it's not always the machine's fault. This is another me stupid idea. The Pokeball there, I forgot that I literally printed the bottom half twice. So I printed both of them thinking one was the top, one was the bottom. And then I got them off and then I was like, oh, that's both the bottom, so that's not gonna work. So it's not always the machine's fault. It's not always the file's fault. Sometimes it's just you forget. The other thing I'd like to bring up is what's called the unspoken bylaws of 3D printing. And mainly because 3D printing is so open source, It's very community-based. You kind of have to work through this system with a level of trust that other people are going to trust and do what you ask them to do. There are 3 files. That means, like I said, I was thinking about doing a 3D printing on-demand service where people bring me a file, or I find a file for them, and I just print it for them. When I do something like that, like for instance, if you wanted to purchase that Pokeball, that's not my file. I can't sell that file to you. It is not mine. I don't own it. I didn't make it. But if you want me to print that for you, I charge for my time to print, the running of my machine, the filament to make that, as well as some people will throw in, and I do it too, throw in the electricity that it takes, as well as a little bit for the maintenance of your machines. But that means that if you get something for free off of Thingiverse, don't go replicating it thousands of times and selling it for a profit. Now, if it's something like this where I printed a base helmet and then I took this and I rendered it and changed it, added eyes to it, because that's the other thing, this doesn't have eyes in it, which was great, but I had to break myself out. So this doesn't have eyes, it doesn't have any facial features, it's just a basic template for a helmet. So if you want to build a helmet, but then you want to change things, that's the other thing, is a lot of these people will allow you to take their file and change it up and do things to it that you want to do. But that's kind of the unspoken bylaws of 3D printing. If you don't own the file, you can't. By all means, charge somebody for it. Like I said, I purchased this one from somebody. Now, I purchased the file, I printed it myself. I think it cost me $15 for the file, which is fair. I feel like that's way less than he should have charged. But those are mainly the unspoken bylaws that I say to 3D printing. It's open source, let's keep it open source. That's the only way to do it. So I guess now we can open it up to questions. Well, that's perfect. We have about a half hour or so for questions. You in the blue basket.
Completely unrelated to this bow that I'm holding.
And what was your question?
What is the...
What do you use to bond the pieces together?
Oh, to glue them together?
Adhesive, plastic mounting, and whatever.
That's actually a really good idea, because actually the sword down there is actually glued with super glue. As well as I use inside to put the stick in it, I put E6000 on that. But the other thing a lot of people use is plastic welding, especially with PLA. PLA, you just heat it up a little bit. You can take a knife, a butter knife, whatever, and you can literally just, like you're fixing a canoe or a kayak. So that's what a lot of people do. Other people will use a what's called a slurry. They'll take PLA, that's this junk, put it in a bottle with some acetone. Acetone melts this. So you can melt it down into a putty, and then you can use it for filling cracks, you can use it for all kinds of stuff like that. So that's one idea. Pink, purple, good. There you go.
What kind of upkeep are you looking at for 3D printers?
Are you considering...
Plastic, all that, like between cleaning and repairing?
Well, now it kind of depends on which printer you're thinking. If you're thinking FDM, there's not really a whole ton of what I would consider upkeep. The biggest upkeep I have is rinsing my glue stick off of the print bed. That's another thing, is printing is kind of something that don't overthink everything. Like I had the problem where this was lifting. One of the quickest and easiest ways to make sure that happens is you literally take a glue stick and just put glue all over your print bed. And guess what? When that print bed heats up, it dries the glue, but it makes sure that that sucker does not come off. Even when you want it to come off, it doesn't come off. You do have clogged nozzles every once in a while, so you'll come home to a big ball of melted plastic sticking out of your printer head. There again, been there, done that. Funny thing about that is, it heated up at one point, you can heat up the nozzle and tell your nozzle to heat up again, and then literally it becomes somewhat liquid again, and you can just pull it right off. I mean, I normally get a brass wire brush, just to kind of clean off some of the excess around my nozzle, as well as purchase extra nozzles. They're simple, quick, and easy. It's one of those things, if you get one that clogs, you can just take the nozzle off, swap it out for another one, and move on with your print. I don't really think I have a whole lot. The other thing is I guess belt tension, because almost all of the FDM printers are run off of a belt-driven system. So every once in a while, those belts will start to stretch out. I mean, it takes quite a while. I have 2 printers, and I've had them for well over a year, and I've never really felt any major issue in that. But it's all about watching your print. The print will tell you what's wrong if you just look at it. And there are multiple, like I said, if you have a problem 3D printing being open source, Google Foo is your friend. Because I can't tell you how many times I have a problem and I literally just Google it. And they're like, oh yeah, that's how you fix this. Because somebody else has had that problem. But maintenance on the FDMs is a little bit easier. SLA, on the other hand, that is a lot more involved. I personally don't have one. I'm hoping to get one in the near future. But with those, you actually have to get a cleaning station so that when you actually take the print off of the actual printer, it has to go into a cleaning station to clean off any liquid resin with isopropyl alcohol. And then, like I said, normally you have to then either build or you put, some printers will actually come with a curing station where you literally put it in and it's just UV light and it spins the print really slow to cure that last layer of resin. So there's a lot more involved with that physical design. But I mean, it's mostly just when things go wrong. It's not so much about maintaining. I mean, as long as you maintain it, you make sure you keep an eye on it and just kind of handle the problems as they come. Trust me, there have been times where I've wanted to throw it out the window. Because I always look at them as they're like toddlers. They are great if you watch them for the first 5 minutes. As soon as you take your eyes off them, they find something to do that you don't want them to do. I mean, that's just the way it is. But maintenance-wise, I don't think they're as bad as, say, anything else. I mean, let's put it this way, I fix cars for a living. There's a lot more maintenance on a car than on a 3D printer. A question up front here as well?
Oh, me? No.
Yes.
I had just wanted to ask something further about bed adhesion, or piece adhesion, but you answered it for me.
Oh, okay. Somebody else? You over there?
Can you talk a little bit about how you deal with the muscle toxicity and this, like, do you need a particular kind of ventilation? And is this something that can be done in a spare room in the house, or do you recommend a garage, like an outside type building?
So I can go yes and no on it. So these prints, there is next to no toxicity with these. I literally can go up. The biggest worry you have with these is burning yourself if you try to take it off the printer before everything cools down. Like I said, the print nozzles, when I run mine, it's at 205 to 210 degrees Celsius. For everybody that doesn't know how to switch that over, 100 degrees Celsius is 212 degrees Fahrenheit. So we're running it at double the boiling point of water. So yes, it will take the fingerprints off your fingers. SLA is a little different. SLA, I always recommend using gloves when you're touching a print that is coming off of the printer. Once it is completely cleaned and cured, it is safe to touch with your bare hands. SLA, you don't really have a whole lot in the way of vapors from it. It doesn't really cause much in the way of vapors. I would say do it in a spare bedroom. That's where I have both of my printers set up, and I don't normally have any problems with them, besides sometimes you hear the noise. But the other thing is in a garage, I would recommend not doing that just because you need climate control, because a lot of this stuff is temperature sensitive. Blue there, you had your...
I actually have a question related to that too. I keep my printer in my living room, which is inside, but do you have to I've noticed that I have to adjust my settings for the season, like for the cold. Do you find that too? I wasn't sure if that was my environment.
I actually did have a bit of a horror story with that. I found out very quickly that you don't want them anywhere near any kind of a ventilation system in your house with air conditioning or heat, because just a gust of air from an air conditioning system will kill a print. I'd come home to a print that was just a rat's nest. And literally I moved them from one side of the room that had venting on the floor to the side that didn't. Perfect.
Can you fix that with a box over it?
Yes, you can, if you wish to put an enclosure on it, you can put an enclosure around it if that's viable to you. For me, it just wasn't at this time. So I just moved it around the room to see if that would fix the problem. But yeah, most people will put enclosures around them, either made out of insulation foam and put a door on it or anything like that. And I would highly recommend that if you go into ABS, because ABS is a lot more temperature sensitive than PLA or some of the other ones.
Would acrylic be done?
Yes, it would be expensive. I would probably say maybe make an acrylic door on the front of it, but build the rest of it plus the roof out of maybe just cheap insulation foam that you can purchase. And that way it's easy, you can see in and check your print. Is that everything? I'm sorry, did I answer your question?
Yeah.
Okay. In the back there?
So I have a couple of 3D printers. I've never thought about the electrical costs for running those. What would you say it costs in electricity to actually run a printer?
On our electric bill, we don't really see much of an uptick. Normally, I leave my printers on, maybe not running a physical print, but I leave them on, and I haven't personally, and I don't know if my wife has seen it. She looks at the bills just as much as I do, but we don't necessarily see it. That being said, I have found people online that have actually crunched the numbers and figured out exactly how much it costs. It's very negligible, but it's one of those things where it's different if, let's say, you're running 2 or 3 printers or something like that, and then you have people that have an entire building that is 20 printers running at the same time. That's a completely different scenario. So in small batches, I feel like it's negligible. I would always, when I quote somebody to 3D print, I always would throw in an extra $1 or $2 on top of my quote just to cover the electricity cost as well as the actual wear and tear on my machine. Over there.
Yeah, so when you're printing, what infill and layer height, where are you usually running?
Layer height is kind of wherever you wish to be. If you want it to print faster, print larger layer height. But that also gives you less detail. If you infill wise, like for instance, this item here is 20% infill. I found 20% infill gives you the nice rigidity, but also gives you the light feel to it. It doesn't feel as super heavy. The biggest thing when it comes to a prop is not so much your infill as much as your wall count. The thicker, the more walls you have, the harder it will be to break. For instance, this helmet I made with 3 walls inside and outside. That's why I had a hard time breaking it. Like I literally have taken this, I threw it across the room and it didn't crack, nothing. And so it's one of those things where that's something that I've learned. Layer height is just for how much post-processing you wish to do. The lower the layer height, the easier it will be. You won't see the layer lines as much. It'll be a little bit nicer cleanup for you. Maybe even just to hit it with a little bit of primer and then sand and you'll be fine. So that's where I would say with that. The blue mask here.
What's the best type of paint you use for the SMR?
Pretty much any kind of paint you can use. I've used automotive paint, I've used acrylic paint, I've used enamel paint. Pretty much it's all about you just want to make sure that you get the adhesion with a primer. I normally try to use a plastic primer that is designed to bond to plastic, but at the same time just hitting it with maybe a 200 grit sandpaper just to give it a little bit of a bite will give you enough for the paint to stick to. Okay.
What's the recyclability on reject plastic? I know you mentioned using it for filling cracks and whatnot, but like, is there someone that I could like send rejects to that they could process into filament again?
There are people that do that. I will say this much, they're crazier than I am. Because most of them actually have to build an actual machine where they have to grind this stuff up almost into a powder, heat it back up, and then physically form it back into a filament. The thing is what's nice about PLA, ABS, and a lot of those other materials, if you recycle at home, those can go right into recycling, and they can be recycled into not just other PLA filament, they can be recycled into any kind of a plastic material. So the renewability of these is very nice. There's very little carbon footprint, I guess would be the best way.
Okay, cool.
How do you stand on doing something like how do you have the 4-lane story gas whenever putting it? Do you have it upright?
Oh, how did I have it set it on the printer?
Yeah.
when I printed it, this is a separate piece. There, I just ruined everybody's. I actually had it sitting just like this. The main reason that I do that is I always look at when I set my files up, where are my supports going to sit? Because this actually has to build up supports, because it's obviously not going to be able to print that and not have it go. So the supports are something you want to kind of hide. So like for instance on this piece, I actually printed it just like this. And you can actually see on the bottom of it, there's still certain layers that didn't bond perfectly, because when they have supports, they don't always bond perfect. But because of the fact that that's facing the inside of the mask, you're barely ever going to see it. So that's kind of the idea that I do. Like when I try to do helmets, I normally try to. This also helps, but then you just have to sand the top of the helmet. So that's basically what I do. If there's any time that I can get away without using supports, I do it, but it also affects your print time. Nurses?
Do you recommend having like a 5-hour like computer to run these programs? Because with me personally, like I have access to a laptop, but I mostly use a tablet, and I don't know. Like do you have to have like a big like something?
You don't necessarily, at least not on the slicer end of it. Like if you're just taking files and you're just slicing them to be 3D printed, you could probably get away with that with most standard laptops, that kind of thing. Blender and other 3D rendering software, I actually just purchased a new tower that is a gaming rig, because my old rig was literally, I would tell it to move a vertex in Blender and it would go, now we're gonna do it. So it was literally, I was moving faster and I couldn't, it was bugging the crap out of me. So it was bogging my computer down. So I was like, I'm gonna get a newer computer. And gaming rigs, you can still get them relatively inexpensively, and they will most likely run Blender or any of those other softwares. I run Fusion 360 on it and I don't have any problems. I run all of that on this laptop. Now this is a gaming laptop as well, but actually the tablet end of it, you actually, if you're, are you using an Apple product?
No, I have
Okay.
a Galaxy.
They very well may have an app as well, because Apple actually has an app called ZBrush that allows you to 3D sculpt in that, as well as VR is a new feature. If you own an Oculus, guess what? You can 3D model all of this stuff in virtual reality. So you can make the Statue of David in virtual reality. So it's one of those things. Tablets have their place and they will work for certain apps, but if you're just doing slicing, most basic laptops will handle it. Here's something.
Adhesion layers, skirts, red trash, do you use them? What have you seen successfully?
Yes, when it comes to adhesion and things like that, I will attempt not to use a raft of all things, because that's actually what caused this issue, where when you put it on a raft, it doesn't necessarily give you a nice smooth bottom, whereas the chainmail here, I actually didn't use any adhesion besides what's called a skirt, which all that does is it makes a ring around it just to kind of get any air bubbles out of your filament, and then it starts the print. So this one went right on my print bed. I actually, because of the glue, I actually had to use a scraper to get this off of my printer. So it stuck nice. Brims are nice. I actually use that to print the handle on that, because I ended up having to print the handle vertically. So a brim was nice because it actually gives you a nice bottom, but it still has where the bottom of that is touching my physical print bed. Because a raft is never going to be as flat of a surface as, let's say, your print bed.
Is there a beginner printer that you would recommend, like brand or that you were printing at the moment?
Well, I'm a little partial, but I will say Creality makes great printers. They have, mine is the Creality CR10S. They have now come out with the Ender 3. The Ender 3s are actually really nice. They're a little bit smaller bed, so if you're planning on printing big items like this, might not be the best thing, but I mean, price-wise, the one that I have, I think we paid, what, like $400 for it? Which isn't an outrageous amount of money, especially when you think about how much people pay to go to conventions and all of this other stuff, especially if you compete. You also have the Ender 5, which is the same basic idea as an Ender, but it's a larger bed. And that one actually is kind of cool because that one, the bed actually lifts. It's not where the bed stays on the bottom, the bed is up top, and the print head just moves on the X and Y axis, and then the bed just comes down. So when you're printing vertically, that's how it works. But there's the Prusas. I mean, a lot of them are right around that price point. It's kind of just figuring out how much you wish to spend. And actually, if you guys are local to this area, I have another business card down there, 3D Makers. He's actually a local gentleman he lives in Columbia, but he's based his business out of York. He actually sells printers, he sells filaments. Zoom training for a certain fee per hour where he'll actually teach you how to use your printer. So you come to him and say, I have this printer, how do I use it? He will literally go over everything. He's very knowledgeable. He's basically figured out how to do everything with these printers. And I work with him now because not only does he do filament, he does parts, labor, service, and he offers, if you're local, we'll offer free delivery. So I can literally contact him today and say, hey, I need this color filament and I need it in a day or two. He will literally drop it off at my house free of charge. And he's another small business started from nothing. So he does not do 3D services as if he would print something like I'm planning to, but he's trying to build a network, including myself, to offer that to his customers. So if a customer comes to him and says, I want something printed, but I don't have a printer, can somebody do it? Do you know anyone? He will vent it out to other people, including myself. So, does that answer your question?
Yeah, thank you.
Okay. Anybody else?
So you mentioned, when you were talking about the amount of layers, you mentioned 20. I'm not sure what you said 20 for field.
That's infill. Infill is basically, the way I look at it is you have an object, for instance, let's say a circle. You have your wall on the outside of the circle. The interior volume of that, you're only filling that with 20% of its volume. So for instance, the chainmail, which I will recommend if you ever print chainmail, printed at 100% infill. So that means that every one of these tiny little links that's in here is a completely solid piece of plastic. There isn't an actually, I can show you this. You see the pattern inside there? That's your infill. So you have an inner wall, which is where it stops in here, where it starts to get solid again, and then you have your outer wall. The infill is that pattern that you have in there. So that's what makes it where it's a solid object, but it's light and weight. 20% is kind of where I feel comfortable with, plus there are multiple different patterns you can use to get different, if you want strength or if you want less material use. And that's the other thing that's nice about Cura. When you actually go in and change settings, you can hover over it, it'll actually tell you, well, if you choose this, it'll be stronger, but it'll use more materials. So Cura kind of puts in little tips inside their software to tell you if you hover over something. Does that answer your question?
Yes,
You were mentioning about with like printing molds and stuff.
Mm-hmm.
With that material, if I use PLA to print a mold, would that be safe to use with casting resin?
I believe it would have to do with the temperature reaction of resin. Just because PLA is very low melting point when it comes to temperature. So let's say if you were going to do something like that, like I personally have never actually done it. I was talking to the gentleman here that I mentioned earlier, and he told me that they just added that feature to Cura with the new update. So it's kind of like a new thing they're just learning how to do. So PETG, nylon, and a lot of the higher temp materials would probably work a little bit better. But like if you have a resin that's a low reaction temperature, so it reacts, but it doesn't get super hot, there's probably less of a chance of your actual mold failing. So that's what I would say. Like I said, I haven't personally done it. It's actually something I've thought about where I would make a master and make a 3D or make a silicone mold myself from that master. But now that I know that I can just tell Cura to print the mold of this object where I don't have to print the master, I can print the mold and then reuse it. And depending on what I use to fill that mold, it might last longer than silicone. silicon only has so many molds in it before it deteriorates.
Yeah.
But that's what I would recommend is just I would say try and do some research on that. Like I said, it's a little bit new. I personally haven't done it yet, so I didn't really do any research on it, but I know it's something that in the cosplay community would be very beneficial.
Do you have another material then that we use in the mold? Like another casting material?
I know some people use resin. Creature cast is actually something that I use on a lot of my props as a encasement instead of plastic dip. It is actually a liquid. It is a liquid neoprene rubber, so it does not react with anything. It literally just pours, hardens, and you have a liquid rubber. And I've used it in place of plastic dip on a lot of props, mainly because some people have reactions to plastic dip. Neoprene is relatively safe on the skin. But that's actually what that product was made for, was to be a casting product. All right, we got 9 minutes. Go ahead.
Have you found like specific brands of PLA to be higher quality, and do you have like a specific recommendation?
The ones I currently use is a brand called Inland, which, when I said that to the gentleman that will now be providing me my filament from now on, he kind of shook his head because it is a very relatively inexpensive filament. It does its job, obviously, as you can see here. It does what it needs to. A lot of filaments, PLA is PLA, and he actually explained this to me better than anybody. PLA is what PLA is. The only main difference between one PLA and another is its color. And when I say that, I mean certain dyes that they put in the PLA will change their melting points. So a purple dye might have to be hotter to melt than, let's say, a gray dye, or a basic dye, or a light colored dye. So it's kind of whatever your preference is, as well as what companies may make certain filaments. There are filaments that they make that are metallic. They actually make filaments that actually change color. There are actually heat conductive filaments. So literally, if I printed this helmet in that filament and I went and took my hand and put my hand on it, I took my hand away, that filament would change color where my hand just touched it because it's heat reactive. There are also UV reactive filaments. There's all kinds of different stuff that you can get. And it's kind of choose which one you feel would work. But I don't personally have a recommendation. I'm okay with trying whatever works, and if I find out it doesn't work, then okay, it doesn't work. I move on.
Are you using it with PLA, PLA Plus?
I use a little bit of both. If I can find a color that I'm looking for in PLA Plus, I would try to use it. If I can't, PLA works for the most part the same. The main difference between what he's talking about, PLA and PLA Plus, is PLA Plus tends to have a finer, it will lay down finer, it will print smoother, it's kind of got a few extra little details. They tend to have a little bit higher of a tolerance to make sure that the filament is the right size. I don't see it breaking as often during prints. I believe that is, if nobody else has any other questions, you can feel free to come on up and take a look. If you want to help yourself to some of the business cards up here, they're mine as well as the other gentlemen's. If you have any other questions that you come up with, I'll be here until 1:30. So.